The derivative of arctan of x is 1 over x squared plus 1, which is a standard derivative. What I'm going to do in this video is prove this well-known derivative. I'm not going to prove the result using the limit definition of the derivative, and instead I'm going to use another method. For this proof, I'm going to be using the fact that the derivative of tangent of x equals secant squared of x without proving it. So here's what we do. We first let y equal arctan of x, and the goal here is to find the derivative of arctan of x. So we would like to find an expression for dy dx in terms of x only. If we take the tangent of both sides of this equation, we get tangent of y equals x. The next thing we should do is take the derivative of both sides of the equation in respect to x. If we take the derivative of tangent y in respect to x, we get secant squared of y times dy dx by the chain rule, since the derivative of tangent of y in respect to y is secant squared of y. We also have to multiply this by the derivative of y in respect to x because of the chain rule, and y is an expression in terms of x, and we are differentiating the expression in terms of y in respect to x. The derivative of x in respect to x is just 1, so the right-hand side becomes 1. We would now like to isolate the dy dx, because we're trying to find an expression for dy dx. So if we divide both sides of the equation by secant squared of y, we get dy dx equals 1 over secant squared of y. Recall that there's a trigonometric identity, tangent squared of x plus 1 equals secant squared of x. We can use this identity to rewrite the right-hand side of the expression as 1 over tangent squared of y plus 1. The reason I rewrote the right-hand side in terms of tangent of y is because tangent of y equals x, which was a consequence of setting y equals arctan of x. This means we can replace the tangent squared of y with x squared to rewrite the right-hand side as 1 over x squared plus 1. This is good because now the expression for dy dx is in terms of x instead of y, which is what we want. So since we set y equal arctan of x and dy dx equals 1 over x squared plus 1, this means the derivative of arctan of x is 1 over x squared plus 1.